Find sine of 2 theta if cosine of theta is equal to 3/5, sine of theta is less than 0. Right, so let's make sure that we look for one, that it's sine of 2 theta, not just the sine of a single theta. And also over here, make sure you understand this means that they want sine of theta to be negative. So it's going to eliminate a few of the quadrants for us. Now, as before, this right here is an angle that we are not sure where it's at. So we can start, by sketching possible locations for this. And again, since we don't know where theta is at, we can start by visualizing or getting a picture for this problem. And I haven't really started with what they're asking us to find yet, but I'll do that right now. So theta could be here, the reference angles over here, and then just create your right triangles for each one. Alright, now they want us to actually find sine of 2 theta. So I have to look at my formulas and what is sine of 2 theta equal to. Okay. So if I go to these right here, double angle formulas, what is sine of 2 theta equal to? Okay, so let's write that. And notice how this one is 2 theta, and then on the formulas it's just one of the thetas by itself. So 2 sine of theta cosine of theta. So I eventually need to find sine of theta. In order for me to do that, I needed this sketch right here. Since I don't know where theta is, I have to use this criteria to help me out, to help me figure where it's at. So cosine is adjacent over hypotenuse. So on my pictures, I have to label adjacent 3, hypotenuse 5. Now based on the location, this 3 has to be negative. And now, what does that mean? If this side is negative, what can I do to these two quadrants? Yeah, I can eliminate these quadrants over here simply because cosine, let's make a note, I can say that on these two quadrants, cosine of theta is equal to negative 3/5, not positive, which is what the problem is telling us that we want. Now, furthermore, it also tells us that sine of theta should be negative. If you wanted to, just look at the signs, but eventually I'm going to need this. How do I find the opposite? Yeah, Pythagorean theorem. Yes, you could use Pythagorean theorem or recognize that it's a 3, 4, 5 right triangle, but it's basically you can do 5 squared minus 3 squared, square root of that, you will get 4. So this is 4, but this one down here is negative. And according to our problem, they wanted sine of theta to be negative. So what does that mean? Which one? Yeah, for these right here, I can eliminate this quadrant, and I'm going to make a note here saying that sine of theta is equal to positive. In this case, it's positive 4/5, but really I'm only interested in the sign, not negative. And I wanted, or the problem stated that it had to be negative. Alright, so that leaves only this quadrant right here. So now let's go back to my problem and start evaluating this right here. Sine of 2 theta is equal to 2 times, instead of sine of theta, now according to my sketch, sine of theta is opposite over hypotenuse, which is negative 4 over 5 times cosine is, well, it was given also, cosine of theta was 3/5, or you can use your sketch, it'll work out as well. Don't forget this is 2, like saying 2 over 1, so I multiply across the numerators, negative 8 times 3 is negative 24, and the denominator is 25. Alright, and I do want you to kind of continue doing these sketches because I know it may seem like a lot of work, and if you look at the book, it also had you memorize, which quadrant it was supposed to be. Like, for example, if you knew that sine was negative, you could eliminate, these three based on where the sine, cosine, or tangent are positive or negative. But I prefer that you do these sketches because, you also use them when you're solving equations, which we're gonna do right now. Any questions?